So you have an activity today called Simplify Fractions Part 2. And what you need to know is these must be turned in before you leave. I will not accept any of them after today, so don't take them with you. Don't sit on your phone the whole time. You have to get this done today, no matter what, no matter who. So we need to practice with our simplifying of fractions, because at the end of our quadratic formula solutions, all of us have trouble with those fractions at the end. So you have 10 questions today. You will not use a clicker. You will make an answer sheet, and do not write on this paper. And please do not leave the blank papers laying all over the floor. Return them to the substitute when you're finished and make your answer sheet. So remember, way back, if you had 2 over 4, you all know that that is 1/2. Well, let's look at what happens in between there. That's really a 2 over a 2 times 2 if you factor out the 4. Those 2's will cancel because one's in the numerator and one's in the denominator, and because it's all multiplication happening in the denominator. If this multiplication sign was an addition or a subtraction, this would not work. When everything in the numerator is gone, that leaves a 1 as a placeholder, which is 1/2. Well, let's look at a different one. Let's say we have 14 over 28. Well, 14 is 2 times 7. 28 is 4 times 7, which is 2 times 2 times 7. And a pair of 2's cancel, a pair of 7's cancel. Since the numerator is empty, we leave a 1 as a placeholder, and the only factor left is a 2 in the denominator. And I think we'd all agree that 14 over 28 is 1/2. This is no different when you add variables to the factors. So for instance, if we had m squared over m to the 4th, if we expanded that out, it would be m times m over m times m times m times m, and 2 pairs of m's will cancel, leaving a 1 in the top and 2 m's on the bottom. And if you remember, when you have exponents and you're using division, you will subtract. 4 minus 2 is 2. That is a shortcut. If you cannot remember that shortcut, then expand it out just like I did. Now when you add factors, let's say number 1, let me deal with negative exponents first. X to the negative 1 is the same as x to the negative 1 over 1. Every number that's not a fraction has an imaginary 1 underneath it. That is the exact same thing as x to the positive 1. Hopefully you remember from Algebra 1 that if you need an exponent to be positive, you move it from the top to the bottom or the bottom to the top of the fraction. So what I mean by that is, if I had 1 over y to the negative 3rd power, that is the same exact thing as y to the positive 3rd power. I moved the y with the exponent from the denominator to the numerator. It's now in the top of the fraction, so the sign of the exponent switches. So for instance, if I had xy to the negative 2 over y to the 3rd, and let's throw a 2 in there just for fun, that would be the same as x over 2 y cubed times y squared. The only thing I've done was move this piece to the bottom of the fraction so that the exponent would go positive, And now when you combine the y cubed and y squared, because those are common factors, that's going to equal x over 2y to the fifth. Now let's look at number 2 on your worksheet. Actually, I'll do number 1. Number 1 probably looks harder to everybody, so we'll do it. So negative 3m to the negative third all over negative n to the negative 1, negative 9n to the fifth times 3m to the negative 1, n to the negative 2. This is all multiplication. No adding and subtracting, which makes my job a lot easier. Now, you can do simple subtraction with this division of exponents. I wouldn't recommend it because nobody's really good at subtracting negative numbers. So what I would do first is I would get all of these n's and I would add up all those exponents. So leave the top alone for just a second. And on the bottom, just leave that negative sign out front. This one right here, leave this for just a second. Now, when you multiply with the same base, you add the exponents. So we're going to have a negative 1 plus 5. That's 4. Add the negative 2. 4 plus negative 2 is 2. So the exponent on my n is a 2 now. So the negative 9 is still there. And the and the 3m to the negative 1 is still there. Now this m to the negative 1, if I move it to the top, that negative 1 will be positive, right? So negative 3, m to the negative 3, move that m to the 1 up top. And if you notice here in my denominator, I have a negative and a negative, all that's being multiplied. Well, those two negatives will end up turning each other positive, so it'll just go away. And 9 times 3 is 27. So I did a little bit of simplifying in that one step. Canceled out the two negatives, and I did the 9 times 3. Now let's look in the top. We have those two common factors, the m's. When you have the same base, you add the exponents. So negative 3 plus 1 is negative 2. So the top of that is going to turn into negative 3m, negative 2, all over. And let's write the denominator correctly. Let's put our coefficient where it goes. N squared. Okay, so I'm going to take that to the next slide. Negative 3m to the negative 2 all over 27n squared. Now I need that m to the negative 2 to be positive, cannot have negative exponents, so I'll just move that whole piece back to the bottom. So it's negative 3 over m squared n squared. I'm going to go ahead and put it in alphabetical order. And let's expand that 27 for just a minute. That's 3 times 9, isn't it? Well, now I hope you see that you have those two common factors that will cancel, leaving you a 1 in the top, and the bottom is 9m squared n squared. So the answer to the very first one is A, negative 1 over 9m squared n squared. Follow that same pattern all the way through. If you'll get all the variables either in the top together or the bottom together, you can simply add up the exponents. Now, if you want to take the chance on subtracting negative numbers, you can. So for instance, m to the 8th over m to the 4th, if you expand that out, 4m's will cancel and it'll leave you 4 in the top. However, when you have division with the same base, you can subtract the exponents. 8 minus 4 is 4, so that goes to 4. The problem comes in when you have negative exponents. So that's really going to equal m to the 3 minus negative 2, which is m to the 5th. None of us are really good at that. My advice to you is to move all of these variables to either the top or the bottom. Now it's multiplication, and you can add the exponents together. Remember, this needs to be turned in before you leave. Don't leave them on my floor, and give the worksheets that aren't written on back to the substitute. Thank you. Have a good day. See you tomorrow.